Hey everyone, welcome to the third lecture of NumPy, in which we will discuss about the arithmetic operations and some of basics slicing of index slicing. Okay, so let's get started first. That we will import our NumPy just as NP. You should also do this if you are doing it, and just create a data. Okay, we'll create an array, and how will we create it? Simple that np.array. Okay, and we'll give some data to it. It's one. It's like we will keep it very simple as possible. So two, three, four. Okay, another five, six, seven, eight. Okay, now this is our array for it. We will create it. Now we will do some simple, actually arithmetic of it. So what we'll do that we'll add one to every. What we're doing that we're adding data. We let's see. Like so, our data looks like this. Actually, it is an array. So it is array in which we have two rows and one, two, three, four columns. Okay, two rows and four columns. Okay. Now what we're doing that we're adding this data. We're adding this data. So what happened actually that we had data in which we had two rows and four columns, which are one, two, three, four, five, six, seven, eight, and we added another data to what happened actually that data plus data. So another data is like this. One was the data, and if we put another that, so what happened actually that one got added to one every position. Okay, so the first one got added to one, two to two, three to three, two to four, and them resulted to it as like one plus one two, two plus two four, three plus three six, four plus four 8. So this happened like this that 10, 14, 6, 10, 12, 14, 16. This happened all like this. So it just simple what happened actually that they got added by their own value. Okay, data plus data. It will be same for this actually that if it data minus data. Okay, same cause we all got subtracted by each other data into data into data. What happened actually that they multiplied it by its own. Okay, so one into one where it is one into one one, two into two four, three into three is nine, four into four six, sorry 16, and that as it is, and data divided by data it will be one actually, because if we divide any number by itself then it results into one actually. Yeah, pretty good. We could see that. Now we could do more with it. If we want to add one to every data, every element in our data, then we can add this. Okay. If we want to subtract one from the every data, we could also do that. If we want to multiply it by two, we can also do that. If we want to divide it by one, we could also do that. If we can also one divided by the data, we can also do that. And this is our the arithmetic thing looks. This is nothing but we can do all the operations that we do it. Okay, we can use all the other like sign and all those values for this. We don't need to go right now actually, but yeah, you can do it if you want to. Now now moving to the next one. If anything left, yeah, yeah, forgot one thing that we can do a square of it. So yeah. So the square of 1, 1. The square of 2 is 4. The square of 3 is 9. The square of 4 is 16. The square of 5 is 25. This is all. And this is what happened if we give the power of 2. So what is saying actually, see, it is a of power. So what happening actually is this, that we are giving it the exponential of 2. What if it 3? Okay, so this is the power. Okay, the power, the uh, x power for it. The exponential. Okay, the exponent. If we give it 4, it will result it. Okay? But for the simplicity, we'll just do 2 because we all know. Okay, so it's nothing but giving it the power. You know the rate of the power. If 2 a square of 2, so it's a sigma to square of 2. Okay, now what we'll do that suppose that we can also do a comparison. Okay, we can also do a comparison in which what we had is that we had a data, and we will create which something looks like this. Now we will create another data. Okay, same same to same like this. No, we won't do like this, but np dot array, which we will start it by 0, not from the 1. Okay, in which we will start from the 0, not from the 1. So 0 1 1 2 3. Okay, and for the second array, in the array we will nothing but we'll keep it the same, 5 6 7 and 8. Okay, now we want to check something, that is this data equal to the data equal to this. So both of them are same. Actually, let's see the data one. Data one looks like this. So are they same? Data equal to sorry, data equal to, why the hell, data equal to data one. So we could see that it is comparing the element wise element wise. What is happening actually is that one is got compared to zero. Are they equal? No. One, two equal to one? No. Three equal to two? No, sir. Four equal to three? No. So what is happened that 5 equal to 5? Yes. 6 equal to 6? Yes. 7 equal to 7? Yes. 8 equal to 8? Yes. Which is true. It is true. Is my data equal to data 1? Yes. For this. For this elements. Not for this. For this, they are same. But not for this. And this is how we do it. We can also see, are they greater than not? Data is greater than data 1. Yeah. True, 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 true. Why? Because in the data 1, we had 0. But in the data, we started from 1. Sorry, 1. Yeah, we started from the 1. So the data is greater than, yes, 2. 0 is 1 is greater than 0. 2 is greater than 1. 3 is greater. 2 is greater than. Sorry, 3 is greater than 2, and 4 is greater than 3. Simply, we could see that here. So these nothing but some the comparison and the arithmetic things that we can do with our arrays. Now we'll move it to another section, which is indexing and slicing. Okay, so we have to get this very clear, that why do we index it. So suppose that we got some data, and in the data we have some particular column which is important. Okay, we had some particular column important. Now we want only that column or row at that particular time. So we need to actually find that, and we need to actually put and find that where it is in the array, and we have to find them and use it. So how will you do it? And for that we use it. Okay, we use it slicing or indexing. For that, what will you do that right now is that we will create another, for three. Okay, we need to mess with our, so we'll create simply array, and we will give it to 10. Okay, so we have array in which we have 10 elements. Okay, 0 1 2 3 4 5 6 7 8 9 10. Okay, so what happens actually that it starts from 0. There are only 10 elements. See, 1 2 3 element, not the number. 1 2 3 4 5 6 7 8 9 10. We have 10 elements. Okay, but we don't have 10 numbers. From the number from the 10, we have 10 elements. We have 10 elements, but not starting from the 1. It starts from the 0. Okay, we have to get into this mind. Okay, now this is the element, and the position also gets from the starts from the 0. Okay, position also starts from the 0. This is the index 1, index 2, index 3, index 4, but the position will be 0. Okay, this is a bit confusing. I will tell you right now that how we can deal with it. But let's get started with our indexing. So what is happening that, so suppose that we want to choose the value 3 0. So we're saying that give me the value in the position 0. And what is the zeroth position? Okay, so let me tell you if, where is my Xcali draw, Xcali draw. I was watching some. Yeah. So, clear it. So what is happening here? See, wait, if I can do, is it bit lagging or what? Some I don't know. Oh wait, man. Okay, why is this happening, man? It's a bit lagging, I think. I don't know, but yeah. Why? I think my soap is slow. Okay, wait. Okay, yeah. So suppose that one, we have an array which four, five. In programming, what happens at number one, it starts from zero. So this is the zero, this is the first, this is the second, this is the third, and this is the fourth, and this is the position. Okay, this is the position. Now, if we say that how much element do we have, then we have five elements. One, two, three, four, five. One, two, three, four, five. We have five elements. But what is the index of it? Index of it nothing but zero. Okay, the first element, the index of the first element is zero, and the second is one, and the third is two, and the fourth is three. The position. Okay, the index. Okay, but their index is actually first, second, third, fourth, fifth. We're saying it in the position first, second, third, fourth, fifth. But what is the number that is used for it? That we actually use it 0, 1, 2, 3, 4. This is what we use there actually. Okay. So what? So we are saying this. Give me the number, whatever you have in the zeroth position. And what is the number we have in the zero position? It's nothing but zero. Okay, if we ask for the 10th position, because we had only 10 numbers. Okay, so if we say ARR, it's 3, sorry, 10th. So it's so much time. Yeah, you saw we got an error. Why? Because I gave it 10th, and what does 10th means is 10 plus 1, which is 11th, but we had only 10 elements. But what if I give 9? See, magic. How? Why? Because what happens that conventionally what we had, it starts from the 0, it does not start from the 1. So if we give 10, then it means the 11th position in the 11th element. If you give it 9, what does it mean? That the position in the ninth element. Okay, the position of the 10th element. Okay, and what is it? Ninth is 9. Okay, so it does not like that I'm giving it the value of 9. No, it's not like that. If you're giving it value of 9, then this does not work like this. Okay, and that is it. And now we have some more, which is actually is like, so now what we want, that we want the history. Suppose that these are days. Okay, zero is the starting day. Suppose that one, third, fourth, zero is the warm up day. Suppose that first, second, third, fourth, fifth, sixth, seventh, and ninth. Suppose a person ran for the 10 days. This is the warm up day. The first day he ran around 100 meters. Second day he ran 300 meter, whatever for the 10 days. Okay, for the 10 days we have only data of 9 days, but actually this is the warm up day, so we're including it. Now we want that how much did the person ran in the fifth and the eighth day. Okay, between the fifth and the eighth day. So what will we do this? Array 3. So what we are saying to the code is that we're saying that give me the data starting from the fifth day. Okay, from the fifth position. Remember that it's from the fifth position. So what this fifth means here is actually 0, 1, 2, 3, 4, 5. This is 5, but this is actually what? 6. See? 1, 2, 3, 4, 5, 6. The element, the position, it is 6. But what is the number we are using for it? It is nothing but 5 conventionally. Okay. So it will start from fifth position, not the element. Okay. And it will stop till 8. And what is 8 here is this position. I'm saying 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. But if we see from the 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the ninth. Okay. Let's see what this gives. It gives us 5, 6, 7. Why? 0, 1, 2, 3, 4, 5. Starts on the 5 and stops at the 7. So this is the fifth, sixth, seventh, and it stops at the 8. Stops at the 8. Okay. It gets stops at the 8. And this is what we need to know, is that this is actually the starting point. This is actually the starting point and this is the stopping point. From this point we will start and from this point we will stop. Okay. And we can also assign some value in it. Like if we want to assign value in it, like wait, yeah. If we want to the person rain around 600 meter every day. Okay. So you could see that this is actually 600. Wow. How? Because we assigned said that starts from the fifth position. What is the fifth position? 0, 1, 2, 3, 4, 5th. This is the fifth position. Okay. And we went from fifth, sixth, seventh, and at the eighth position we got stopped. And what is the value in the fifth, sixth, seventh position is nothing but 600. So yeah, that was something that we need to know. Now, if we want actually to assign every value, okay, every wait, so we'll do just, so we are saying that start from 0 and end, start from the first and and stop at the last. Okay. And if we want to add one, this, and assigned it 1, and this will convert into only 1. You could see that. Wow. How? And this is what we do actually, because if we want to change the value we can do it by it like this also. Now what happens actually is that in the NumPy, so we need to know something, very important thing is that it does not become a copy of it. Okay. It does not become copy of it. What does copy of it means? That if we initialized an array and we did some manipulation in it, then it does not change. Okay. It get changed. It does not like that I will give it you a new address for it by with the same variable and the values. No, it does not happen in the NumPy, because we need to understand that NumPy is actually built for the large data. So if we ask why, wait, let me do a markdown. Yeah. So uh why do we why do we why don't we, okay, why don't we copy in NumPy? Because NumPy has been actually NumPy has been actually designed designed to be able to work with very large data. Okay. With very large data or array. So if we have a concept of copying that, then you could imagine that you could imagine that the performance and the uh, memory problem of it. Okay. If we always copying, then how that we can manage from it. So for that purpose, we actually don't copy NumPy. And if we want to actually copy it, so what we could do that array 4 and we want to copy actually our same the initial 5 to 8, then we could use copy and it will copy it and it will copy it. Wait, and it will copy it. Oh, sorry, it is AIR, not AIR, it's ARR. It's ARR and it will copy it. And if we see 4, then yeah, here we have. Okay, here we have. So this is the thing we actually work with. Okay, now human, it's been, so I'm running out of time. It's been 20 minutes I'm recording it, so I will stop it because I don't want to be this video so long. So thanks for watching till now, everyone, and thanks for giving your valuable time till now. Okay, so bye, meet you to the next video. Bye bye.